Hello and welcome to Food Safety Fridays. My name is Simon Timperley from the International Food Safety and Quality Network. Today's guest is Maria Sandoval from Trace Analytics, and today the topic is Beyond the Pass and Fail, Identifying Compressed Air Contaminants. So first of all, welcome. Happy Friday, Maria. How are you?
Thank you. Doing pretty well. We're finally getting good weather in Austin.
Well, that's nice. Yeah, it's nice and bright and sunny. A bit chilly, but at least we've got some sun. And we've just been saying it's the last day of February today, everybody. Can you believe that? So tell us where you're joining from in the sidebar. It's always good to see you. Charles, hi. Lee, hello. Balasandaram, hi. Good evening. Hakan, hi. Naidi. Boa tarde. Is that Portuguese? The Brazilian? Maybe. Anyway, I'm going to play the sponsors ads now, of which Trace Analytics are one of our kind sponsors, and we'll be back with Maria for the presentation shortly. Okay, I'll be back for the Q&A at the end, but for now I'll hand you over to Maria for the presentation.
Great. Hey guys, thanks for joining me today. We're going to be talking about Beyond the Pass and Fail and identifying compressed air contaminants. So let's go ahead and get started. Like Simon mentioned, I'm from Trace Analytics. We are a compressed air testing lab. We were established in 1989, so we've been around for quite a while. We're A2LA accredited, which means we adhere to ISO 17025, and we have a regulatory body that we need to maintain compliance with. We test to many regulatory bodies and standards, including but not limited to SQF, BRCA, ISO 8573, and so on and so forth. We have members from the Trace team that collaborate on and contribute on the NFPA 1989, ISO 8573 committee, as well as ISPE. We've been very fortunate to be able to acquire some state-of-the-art technology to further advance our testing capabilities here, and we work with clients all around the world. So I see many of you guys are from different countries, and I urge you to give me a call, give us a call, contact our customer service or sales team if you guys have any questions after the webinar today. So like Simon mentioned, my name's Maria. I've been the lab director here at Trace Analytics for a few years now. I started at Trace 7 years ago as a microbiologist and moved up there. I have over 20 years of experience in microbiology and molecular biology. Currently, I'm the project leader of ISO 8573. That is the compressed air contaminant international standard. And I encourage anybody who's on the call who's interested to be a part of building those standards to reach out to me, and I'll get you in contact with the technical committee member who can help you enroll. We're always looking for innovative people, thinkers, and great ideas for compressed air testing. I'm also on the ISBT gases technical committee. So right now we're looking at revamping the carbon dioxide technical standard as well as compressed air. Also on the 3A sanitary standard, NFPA 1989 and ISPE. So what are we going to talk about today? Today we're going to cover contaminants and what to look for. So if you guys have attended any of my other webinars in the past, you know that I love compressed air contaminants. That's all I do. That's all I talk about. Particles, water, oil, microorganisms. So we're going to talk about, just briefly to make sure everybody's on the same page, particulates, water, total oil, microorganisms, what standards can be used to guide you into testing, what some regulatory bodies are asking of you when they ask you, hey, you need to make sure that your compressed air isn't cross-contaminating your end product. Then we're going to move on to understanding your results. So you finally get some guidance on you needing to test your compressed air. Now it's time to read the report. What are you going to do with it? How are you going to make the report work for you? What are some common causes of failures? Things like that. And then how can you make the report even more powerful by further identification? So what are some cool test methods that are available once you do get results? How do you understand those results, and how can you troubleshoot using the information provided to you by the report? So those are some things we're going to talk about today. But as a little visualization, I want you to look at this diagram here on the screen and see that the compressed air is being intook into your compressor system, and it's going to have all of the contaminants at the intake. It's going to have oil aerosols, waters, lubricants. It's going to have metals from wear, scale, rust, microorganisms. Then you go through your first line of defense, which is pre-filtration. And that's when you start getting rid of some, not all, of those contaminants. And then you add another level of filtration, and hopefully you get to the endpoint of clean air that is compliant with the air purity standard that you guys are looking for. So here is my shock and awe for you. This is compressed air testing. What is it? Well, many of you guys are in the food industry, and you are asked by SQF or BRCGS to make sure that your air quality is not contaminating your end product, not harming your staff. And to do that, you need to be testing. So why do you need to test? Well, the quick answer is so that you don't have a catastrophic issue like the images pictured here. So what you're seeing on the far left is a picture of a compressed air piping system that has rust, scale, particulates in it. A lot of this stuff is happening, and we'll get into the cool science of it in a little bit, but a lot of this is happening because of water, and the water is corroding the inside of the piping system if you're not choosing the appropriate piping composition for your usage of air. And what that looks like is you get a membrane like the one below that has particle contamination, oil aerosols, and things like that. When we're moving to the right a little bit, you see a microorganism plate. Now I know what you're thinking, well, that's not in my air, but it is actually. So particles are viable and non-viable, and this is an example of viable particles that came from a compressed air sample point of use. And you may be thinking, well, Maria, I breathe in a lot of microorganisms in the air. Why is this such a big deal? Because these organisms are compressed into 1 cubic meter of air at any given time. So if you're blowing it into a chip bag or something like that, or a ready-to-eat meal, it becomes problematic because the organisms are compressed in a concentrated state. Next, we have water. Now, this is a gloomy picture of the condensate dump. But if you have this kind of murky and unkept area, you need to be thinking about what does the line look like, and what do the condensate drains look like at your points of use. And finally, we have oil. If you have a catastrophic failure of your O-rings and you have a complete leakage of lubricant and oil, you can see this amount of oil come through your system and as a catastrophic failure. And this is an example of that. Liquid oil getting onto an oil aerosol and particulate test. So how do we avoid all of that? Well, we avoid all of this by telling ourselves, okay, we know we are using compressed air. It is the fourth utility in the world. It's up there next to water usage and electricity. Not many people are hand mixing their mixtures anymore. They're using compressed air. And so with that, you need a risk-based standard that can help you understand what type of purity you need for that point of use. And that's where ISO 8573 comes into play. They give you a guidance tool to choose the purity class that your risk assessment deems appropriate for your end product. So ISO 8573 is not telling you, hey, your endpoint needs to be a class 1. What they're telling you is, based on your risk assessment, you can use a purity class 1 to meet that need. And then the following standards, so it's a 12-part standard system, the following chapters will tell you how to meet that purity class. And so what you see on the table here is the 8573 purity classes. Some of you guys may be familiar if you're in a regulated system. It shows you purity classes for particles, water, vapor, and oil. And I do want to remind you that particles are viable and non-viable. So microorganisms and non-viable, metal shavings, rust, particulates, things like that. So that's what you're seeing here. So now that you have an idea of what can guide you for the test methods or what to ask a compressed air testing lab to do for you, you need to know what the regulatory bodies are asking of you. So that's the second piece to the puzzle here. So SQF and BRCGS provide requirements for compressed air systems to ensure that your air quality is meeting the appropriate purity classes required and to prevent the product from further contamination or any contamination at that. It also requires that you have a maintenance program, that you are doing proper cleaning, that your hose reels are not touching the floor. There are requirements for that, as well as air quality testing requirements based on your risk assessments. So when you're trying to identify and categorize the risk, you need to remember, and I touched on it a little bit, there's direct contact, indirect contact. Those are typically regulated bodies. So your quality control department and your facilities department are likely very familiar with this language. But if you're unregulated and in food, and you have a non-food contact place, then you can also use this type of risk assessment to identify or categorize the risk for that point of use. So the first thing you want to do is identify the hazards. Then you want to go in and establish a critical control point. So HACCP is very familiar with all of you guys. Then you want to establish preventative measures. And that's purification, that's filters, that's dryers. You want to move on to monitoring prevention measures. So once you establish it, you have to be able to maintain it, and you can only maintain good preventative measures by testing. You are not capable of maintaining a good, healthy system without testing. After that, you need to establish corrective actions. What are you going to do if you get a failed test? And that's what the remainder of this discussion is going to be about. And then how are you going to maintain those documents? What are you going to do to further the power of your report? So let's get into that a little bit. First, one thing that happens is you need to figure out the source of contamination. So there are different areas that can cause contamination. Obviously, the ambient air, which we talked about. The inlet of a compressor always takes in ambient air. And that ambient air is going to be dependent on the location of the inlet. So is your compressor outside or is it inside? Is it in a HEPA room or is it in just a regular room? Then what does the compressor look like? Is it oil-free system? Is it an oiled system? And your air receiver. That's also another point of contamination. And then lastly, so is the piping. So let's start. How are you going to read your report? So if you are lucky and you choose Trace Analytics to run your compressed air testing, we're going to give you, for particles, water, and oil, it's considered an ISO 8573 test report. And that's what you're looking at here. This has a purity class for particles as a class 1, which you can see in the middle of the section there. It says purity class 1. And it says limiting characteristics on the left. And then on the far right is the pass-fail designation. So the ISO 8573 specification limits are right to the left of the pass-fail designation, and to the left of that are the sample results. So this is an example of a compressed air point of use report for the health of your system in this given time for particles, pressure dew point, and oil. So you can see here this report has failed all three things, but it's not telling you much more than the quantitative value of that failure. So it leaves you with a couple of questions. How did I fail? Or what do I do now? For the micro report, again, microorganisms are viable particulates. So when we look at particulates over here, this is viable and non-viable put together. It does not differentiate between viability and non-viability. For micro reports here, this is strictly viable microorganisms. And again, it's just giving you, this is a basic package report out of 48573. And it's just telling you what the total microorganism count is in 1 cubic meter of air. So you can see here, you have 3 types of controls: a sterility blank, which makes sure that the laboratory or whomever sent you the media didn't cross-contaminate it. 2 blinds, before and after, which tells you, hey, during the process, you didn't cross-contaminate your sample. And then you have the main sample, which is just telling you that you have 5 microorganisms. So again, it's not telling you what type of organism or any further identification is that. So that's where it comes into play and the importance of further identification. And so when we're thinking about the importance of that, we're thinking about what more information can we ask of the results from our third-party laboratory? Can they identify the oil vapor in my oil sample? And the question is, and the answer is yes, we absolutely can. We utilize a GCMS, which is a gas chromatography mass spectrometry system, to identify hydrocarbons that are C6 and higher. We compare those results to a NIST traceable library to give you a score and an identification of the compound that we found in your compressed air. And we'll get into it in a little bit of how you can use that for troubleshooting and corrective actions. Next, we can look at particle identification. So it is possible to do further identification by using a scanning electron microscope. And what that can do is look at the particles and then down to an atomic level tell you the composition of the particles, and then infer based on the composition of the particle what the material could be. For instance, if you have black iron piping, then the SEM would tell you, hey, this particulate is iron. The lab will tell you it's black in color, and then you can infer that it is black iron. And if you have a black iron piping, you could make that further inference. And then finally, for microorganisms, you can use genotypic or phenotypic identification to get to the genus and species. Here at Trace, we use phenotypic identification. We use a biolog system. And it's plenty of power there. As many of you know, I'm sure when I drop Listeria, Salmonella, Clostridium, you guys already know the importance and the power of identifying genus and species. But let's start from the beginning. So let's look at this particulate result here. What we're seeing is we passed for the size of particulates at 0.1 to 0.5. So, hey, cool. Our filtration is working enough to get those sizes out. But we failed the next size. And that next size is 0.5 to 1 micrometer. So I want you to think to yourself, when you're thinking about troubleshooting, what are some of the obvious questions you want to ask yourself? And it should be things like, is my point of use filtration working properly? Is my point of use filter able to meet a class 1? Is my point of use filtration able to meet a class 2? In this case, let's say your point of use was only able to go to a coalescing filter that is able to meet a class 2. Well, then inherently you would tell your quality department, hey, this filtration's not right. It's only good enough for a class 2. We need a better coalescing filter or a carbon filter that can meet a class 1. And that is the type of troubleshooting you can do with these reports. And then you can make an inference about your maintenance schedule. And a lot of that is powerful because if you start doing trend analysis, and I know everyone here on this call is testing quarterly because that is the best way to do it, you could say, all right, I know in January everything was going well. Our particle counts were all zeros at this point of use. And then I tested during quarter 2 and I had this huge uptick. And then we tested again in quarter 3 and we were fine, and quarter 4 was fine. So what am I thinking? Well, I'm going to go look at the maintenance schedule around quarter 2. And then I'm going to ask myself, did it actually fail in April or did it fail sometime before April? And was there some sort of maintenance? Was there some sort of new protocol that rolled into place that could account for this type of failure? And these are the questions that you can ask when you're looking at your HACCP, when you're talking to your quality department. So that's the power of trend analysis. Again, if you only test once a year and you test in January and you don't test until the following January, what would have happened? What would have happened is you would have missed this uptick in April, and maybe your product would have left your doors potentially cross-contaminated. So again, the power of quarterly testing, the power of trend analysis, the power of making your report work for you. When we move on to water, it's the same situation. So you want to be doing quarterly testing. Why? Because there are seasons, and every season has different moistures. And unless your entire system is inside of a temperature controlled, humidity controlled atmosphere, and you know for sure there's no leaks, no one can really know unless you're testing, the power of trend analysis is where it comes into play. So here's another example. We test in January. Everything seems good. Again, we test in April. Not only did we fail for particulates in April, we failed for water. So pressure dew point. We have alert levels, we have alarm levels, and we failed beyond those levels. But sometime in July, we passed. And then at the end of the year, again, we passed. So I say again, if you're only testing once a year, you would have missed this uptick and it would have been beneficial for your maintenance schedule and for your good facility practice to make sure that you guys are thinking about the constant evolution of your compressed air system and the dynamism of compressed air itself. So let's move on now to my fun part, which is oil aerosol. Oil aerosol results are sometimes given from laboratories with a less than sign. Many times our customer service team gets this phone call. So I do want to take a moment to kind of explain this to you. So if you ever receive a report from a third-party lab that has a less than symbol in front of the value, what the lab is saying is that this result is below the limit of quantitation. So what does that mean? That means that it is below the concentration that can be both detected and quantified accurately by the laboratory. So that is what the less than sign means. So a lab cannot, in good conscience, report a 0 for this particular contaminant, but they can tell you, excuse me, based on their limit of quantitation, that it is below that level. Now, ISO 8573 asks that you report total oil, and total oil is the summation of oil aerosol, liquid oil, and oil vapor. So we have oil aerosol here, and then we have oil vapor. So if we look at oil vapor, let's look at this number, 0.087. This is the main driver of the fail of the total oil report out. And so at Trace Analytics, we provide you the further identification of those oil vapors. So if we move your eye down a little bit, you'll see I circled in red, it says oil vapors, pinene 93. So pinene is the hydrocarbon that was identified in your compressed air. We identified pinene with a concentration of 0.087. Your oil vapor value is 0.087. So we know, based on this report, that all of your oil vapor found in this sample is from pinene. The 93 next to it says that we are 93% sure that based on the NIST traceable library, this is the compound found in your compressed air. So the next really cool thing that you can do once you get this report is go online and you can Google pinene. Once you get some results on pinene, you can do a little investigatory work. So pinene is a terpene cleaner. We know this. Many of you guys have pinene at home in the form of a cleaning agent, pine sol, but it's also added in a lot of industrial cleaning agents. So using the internet, using your compressed air report, you can get all of this troubleshooting information to help your maintenance program, to help your quality department troubleshoot how to make corrective actions. These types of reports should not just be a task that you check off and move on from. They're a tool in your toolbox, and they should be used. So that is the power of us identifying your hydrocarbons. Now, one step further that Trace does that many other companies don't do is provide you the other vapors that are not added to your total oil value. So what do I mean by that? So let me slow down. Total oil is the summation of oil aerosol, oil vapor, and total oil. But oil vapors are clearly defined through ISO 8573 as hydrocarbons. So tributylamine is not a pure hydrocarbon. So it is not added to your total oil vapor value, but we do still provide the concentration that we found in your compressed air sample on your report so that you can look into it and use that also to troubleshoot. Now, again, using the internet, you can find that this compound is found in lubricant additives for machinery, dyes, and surfactants. So using that tool, you can kind of make an inference in your mind. Maybe you've been seeing somebody on the cleaning crew cleaning with a pine sol cleaner or some sort of aromatic cleaner near the inlet of the compressor system. That should trigger, hey, this is good troubleshooting. This is a good way to try to see through bootstrap science how we can investigate the resolution of this corrective action. And again, tributylamine is not a hydrocarbon, but we do provide that number. So moving on to micro. This is the one that kind of scares food industry folks. I want to be very cautious. There are millions of species of microorganisms. There are millions of different bacteria, fungi, yeasts. So let's take a breath and realize that, yes, without doing further identification, you don't know. So I will say that. So when we're looking at this report, which is beyond the one that said, hey, you just have 5 organisms, this one's telling you, hey, these 5 microorganisms actually are gram-positive rods. But without further identification, you're left with wondering, is it Clostridium botulinum? That's a big deal if you're in canning. Is it Bacillus cereus? Big deal if you're in foods. Is it Listeria? Big deal if you're in dairy. Or is it staph, which is a big deal if you have a cleaning protocol. So you're left to not actually know. And that's because you haven't further identified. So when we go over here to the further identification, this specific report was actually identified as Bacillus lichtiformis. And what this is this is a naturally occurring microorganism. It looks like this pretty little shape down here because it looks like lichen, right? It looks like something you would see on a tree. Bacillus lichtiformis is typically found in soil and on bird feathers. Can also be used in fermentation industries as well. But more important to the story is that with further identification, we were able to say this gram-positive bacterium is a spore former, which means it's not Listeria, because Listeria doesn't make spores, but it is in fact Bacillus lichtiformis. And what does that mean? Well, it means it's possible for you to look at the inlet of your compressor or any of your points of use. Now, this is an extreme photo, which kind of made me laugh on the inside. So please giggle with me because I really hope none of you guys have birds nesting in your compressor systems. But if you do, it is possible, right? I told you Bacillus lichtiformis is found on bird feathers. It's found in soil. So this is a way to troubleshoot those types of situations. So in theory, you get this report back, you can start cleaning up your situation. You can start making a better cleaning protocol. So these are all the powerful tools of troubleshooting with the reports. Being able to go through your sample points and say, I need to test before and after the filtration and dryers because I have points of use all along that stream and I need to know where the contamination is coming from. And you won't know by assuming. You won't know by assuming that a filter is working properly, or you won't know without doing the further identification. Next, we talked about the importance of frequency. So when we're talking about frequency, this is something that is near and dear to me because I really, really want you guys to understand the power of compressed air testing. And really the power comes from data, and data is more powerful the more data points you have. So quarterly testing is highly recommended, partly because you have seasonal changes, partly because you guys have maintenance changes that are required quarterly. And all of those things combined compound the effectivity of your testing when it comes to quality of the air coming from your point of use. Additionally, there have been many other scenarios that I haven't mentioned that have shown the power of testing your compressed air and doing further identification. One of those crazy case studies is a manufacturer was having some issues with hydrocarbons contaminating their system. They did their whole HACCP and hazardous risk assessment, and they started troubleshooting. Okay, we know that it's coming from this pipeline system, but we can't figure out what the source is. Is there a leak somewhere? Is there a lubricant that's being added to only one O-ring and not another? And when they started testing, they were finding, okay, that's not the highest point of contamination. It's over here. And they made their way finally back to the vessel. They opened it up, and because you can open up your air receivers and all these things, they opened up and they found a glove inside, which was actually off-gassing hydrocarbons in this situation. They were able to remove it, do some further cleanup, test again, and they were able to pass for the air purity that was required for that point of use. So again, using their testing reports to help them troubleshoot. And then lastly, we had manufacturers perform regular testing before they do maintenance. And the results were showing that their dryer was malfunctioning. They were able to do emergency maintenance and save an entire batch of product. And this, again, you don't know these things are happening if you're not testing. And if you're having such severe issues or timely issues, I urge you to call us and talk to us about our real-time data providers, like our laser particle counters, our detector tubes, things like that. All of those can give you real-time data for you to troubleshoot on site with your facility, make some changes, troubleshoot again, run the test with the laser particle counter if that's what you want, and then provide the passing results. So all very powerful tools to make sure that your end product is the best that it can be. So as I wrap up today, say again, quarterly testing is something that is very, very important. I want to leave us enough time today because this is something that it can be difficult to understand how you use a compressed air testing report to troubleshoot. So I welcome all of your questions. Again, I am here if you have any other questions that we didn't cover today. My email is at the bottom as well as my phone number. And with that, I will kick it back to Simon so we can get on with some questions. Thank you guys so much.
Okay. Thank you very much, Maria. Do you want to put your webcam back on? Then we can put it like that and leave this slide on. That'd be good. Okay. Let's get into some questions. So George so if you have a question, just post it now and we'll get into it. So George, question. Hello from Greece. Could you please give us microbiological specs and limits for compressed air? Thank you in advance.
Hey, George. Yeah, absolutely. So there's a couple places you can look at. ISO 8573-7 is the compressed air microbiological contaminant chapter. And when you look into that chapter, it will tell you the sampling system you need to use. So it's going to tell you the type of instrument to use. It's going to tell you what your limits need to be for your controls. So you can't have any growth on any of your controls, sterility blanks, or your blind samples. What it's not going to do is tell you your compressed air microbiological limits. And that's because that A is not provided by ISO 8573, but B, it's because so many facilities are risk-based as well as the end product requirements. So you are encouraged to do a HACCP risk assessment, determine what your limits should be, and then you can use 8573 to meet those. However, there is 14698 and 14644. So 14698 is the biocontamination control, which also discusses compressed air. It also discusses textiles, surface cleaning, and things like that. But again, what it's not telling you is that you can only have X amount of microorganisms in your compressed air. There isn't one out there yet. There are some committees trying to build it out, but it doesn't exist yet. So it is HACCP derived.
Okay, thanks, Maria. Question from Atil. Hi, Number one, is there any standard? We'll just take these one at a time because there's 3 questions, I think. Hi. Number one, is there any standard for gases such as CO2, nitrogen, mixed, etc.?
Okay, so if we do the first question, yes. The answer is yes. It's 8573 part 6, 9, 6. It's one of those. But yes, and we can also do that here at Trace Analytics. That was not something mentioned here, but Simon has a talk from me over modified atmospheric packaging where I discuss this entire process. But yes, there is a standard. It's 8573-6 or 9, and it specifically discusses gases, CO2, and how to test for them. What it doesn't do, though, is tell you what the limits are, and that is because there are too many requirements based on risk. So you would need, again, similar to microbiological, to do a risk assessment.
Okay, what I'll do is I'll dig out that webinar and include it in the follow-up email. And while we're on that, just to say it is being recorded today, and we'll send an email afterwards with the recording, the slides, a certificate, and also a link to that webinar that Maria's referred to. So question number two from Atil, what do you recommend for changing frequency of water oil particle filters?
So that is going to be a recommendation based on the OEM of your filtration. But aside from that, if you are doing quarterly testing and you find that your filtration, regardless of the OEM recommendation, is not providing you with the purity that your point of use needs, then you should consider, based on risk, of changing out that filter more often than what the OEM is recommending. And that's just because you have empirical evidence, because you're testing quarterly, that it is not, or it is you're testing at the rate of the OEM, that it is not upholding its end of the bargain.
Okay, and the third part of the question, what do you mention for compressed air? I'm not sure that word, compressed air, VSLID, for oil-free compressors.
Yeah, so I can infer what he's asking. Is basically, what do you recommend for oil-free compressors? And my answer to that is kind of silly. There's also another oil-free compressor talk that I did at Simon. But what I will say is an oil-free compressor is not completely oil-free. It's that the oil and lubricants that are used in the compressor are in a closed system. They're in a closed loop. But like any closed system or any closed loop, it is imperative that you are maintaining control of the O-rings and the pistons, and you are looking at the health of the lubricants. So what does that mean? It means that if you, for whatever reason, are having a lubricant leak into your pipeline, and you add it with water, and you add it with some pressure, because your lines are pressurized, what you end up doing is having a catalytic effect, and you cause a chemical reaction that causes acidity, it causes corrosion, and those are the types of things that can happen for oil-free compressors if the oil system is not kept in a closed loop.
Okay, thank you. A question from Amir. How do you identify microbiota through Biolog Omnilog?
So microbiota is a fancy word for the microbiology community that is captured from your compressed air, right? So microbiota is all of the organisms that you capture from a sample. Now, how do you identify it using a biolog? You identify it using a biolog using a 96 well assay. So basically, the biolog is a phenotypic tester, and you have a 96 well tray. So I need you all to imagine 96 cups, and I take a little piece of the microorganism, one colony per plate, and I ask it 96 questions. How do you like your sugar? How do you like your environment? Do you like it acidic? Do you like it basic? How do you like X, Y, and Z? And so you're asking 96 metabolic questions. And through those answers, you get a color change. The instrument itself will tell you, hey, based on these 96 questions, this is the score of the genus and species of the microorganism you challenged us with.
Okay. Here. Question number 4 from Atil. If the company has PPRC piping systems, is there also problems related with the corrosion by water and oil vapor?
So I am not specifically informed about what PPRC piping is, but what I can tell you is that lubricants plus water plus pressure, add a little heat in there, you will get a catalytic effect. You will get a chemistry effect, and that is just natural. Now, whether or not it degrades the inner lining of your piping system, that is completely up to the composition of your piping system. Now, if you go and visit our website, we have a best practices, best materials table. So you can go in and see, maybe PPRC is on there, see what the best composition of compressed air pipeline composition is best for the higher purity class requirements.
Okay. Naveen is asking, hi, I'm also looking for specs limits for compressed air testing in food manufacturing.
Yep. And so you're going to use, typically you guys use SQF. SQF will then tell you broadly, hey, we're just asking you to make sure that it doesn't cross-contaminate your end product based on risk. Then you will say, okay, I'm adhering to SQF, and by adhering to SQF, I'm using ISO 8573 methods and guidelines to adhere to SQF. Now, when you get into ISO 8573, you're left with multiple classes that you can pick from, right? So you can pick from, let me get back to that slide. You can pick from any number of particulate classes or water classes, same with total oil classes. And you have to do a HACCP risk assessment to determine whether or not that purity class is going to be good for your end product. So risk assessment all the way. Okay,
question from Mark Anthony. Can microorganisms survive when passing through a compressed air system, especially at high temperatures?
I know many of you guys don't want it to be true. The whole evolution of microorganisms is that they divide every 20 minutes, okay? So humans get 96 years for one generation, right? If you're lucky. Microorganisms get 20 minutes. So in 20 minutes, they evolve to the next generation and the next generation and the next generation. So my answer to you is absolutely. Microorganisms have survived all of the environmental changes that the world has gone through because they evolve so quickly and because they adapt to high environmental changes like compressed airs. In fact, there's an entire population of microorganisms that love high pressure. They're called barophiles, B-A-R phile, so pressure lovers. Additionally, high temperature is great, right? Do you know what a spore-forming bacteria is going to do when it gets to high temperatures? it's going to take all its genetic information, it's going to hug it into a capsule, also known as a spore, and it's going to say, all right, my body's going to die, but all my genetic information is going to be trapped inside of this nuclear envelope until the temperature becomes more amendable to its environment. And then it's going to say, all right, it's safe. It's safe for me to start dividing again. So yes, absolutely. Microorganisms and spores primarily can survive high temperatures and pressure.
Very clever, aren't
Yeah.
they? Question from Stephanie. Do you have a positive experience with the CAMTU sampler for micro sampling?
So the CAM2 stands for Compressed Air Microbiological Testing Unit. It is a indicative piece of equipment. So what do I mean by that? If you go to the OEM of CAM2 and you go into the manual, it will explicitly say that the results cannot be quantifiable. They are qualitative. So it can tell you, yes, you have microorganisms. No, you don't have microorganisms. But you need to remember that ISO 8573 requires quantitative results, not qualitative. They don't want a present or not present, detected, not detected. That is what CAM2 can do and can only do. And it is inside of the manual of the CAM2. Now, ISO 8573 requires that your equipment used is a quantitative piece of equipment. So the CAM2 is not appropriate for ISO 8573 testing.
Right. Clear. Thank you. Question from Gurpreet. Are there rapid or on-site testing methods available for verifying gas purity?
So there are a couple of online, online CO2 meters, CO meters, but it's not going to tell you that your air is 100% nitrogen or 20% oxygen, 80% nitrogen, if you have like a map system. But there are some online testing methods that can do contaminant gas testing.
Okay. Question from Willie. How do we determine which air classification we must comply with according to regulations?
So really that comes down to your risk assessment. But I can give you an idea. If you go to our website, airchecklab.com, and you go into our supportive text, we have a table that says direct contact, indirect contact, and we have, over the generation of our 40 years of being in service, I've shown a table that shows you what a lot of customers are testing for based on direct and indirect. And then there are requirements of BRCGS for certain purities. So depending on what regulation you're looking for, SQF may not have it, but BRCGS definitely does have a requirement. So I would say go ahead and go in there, read the fine print, and make sure that you are actually compliant.
Okay. One more so far. From Gurpreet again. How does the material of the gas tank stroke compressor tank affect safety and purity of gas, and what is the best material to use?
Yeah, so again, when we talk about tank safety, that is going to be, and I always tell Simon, I feel like it's a cop-out to never answer these types of questions, but to instead answer them with, it's a risk assessment. But really, a lot of this is dependent on your end product, the end use of that point of use. But a lot of the times, the compressor tanks are fine. You just need to make sure that you are adhering to the OEM recommendations of cleaning and preventative maintenance. And then if you are doing the quarterly testing near the receiver or after the receiver, then you will have an idea of the health and safety of your system. But you're never going to have an idea if you're not testing. And that's the point here is, a lot of these regulations are telling us that we need to be monitoring. We need to be making sure that we don't cross-contaminate our product. But the kick is you can't monitor without testing. So let's just make sure we're on a quarterly testing schedule.
Sounds good. Okay. Any further questions? I think that's the last one.
Go.
Gail, yes. Don't worry. We will be sending the recording afterwards, the recording, the slides, and the certificate. So don't worry. Any more questions for Maria whilst she is here? I've got a couple of minutes left. I'll put your certificate in the sidebar anyway, and then you can be downloading that to save a bit of time. Yeah, any more questions? Nope. No problem, Gail. No, I think that's it for now. So yeah, we'll dig out the other webinars that have been referred to. Which ones were they specifically, Maria? So we've got the modified atmosphere packaging one, oil-free compressors. Is that another one?
Yeah.
Yeah. Okay. So I'll include links to those two, so you can do some further research. And if you have a question, your contact details are in the PDF of the slides that you'll all receive. So if something comes to mind, you can always drop Maria and the team an email, and they'll surely help you. All right. Yeah. Can you see any more questions, Maria?
Yep.
No. Very good. All right. Early finish, 3 minutes early. The weekend starts 3 minutes early today. So
thank you guys so much.
Yeah, appreciate you, Maria. Have a great weekend, and we'll see you on the next one. Thanks, everybody, for joining today and engaging and posting your questions. It makes it so much more fun. We'll be following up with an email in the next hour or so, and we'll see you on the next webinar. Take care. Bye-bye.
Thank you. Bye-bye.